Hi students, today I am going to solve question number 5 and 6 from SC Verma. Electric field and potential. Let's see what is the question number 5. In question number 5, find the electric force. You need to find out the electric force between two protons, two charged particles which are called protons separated by 1 Fermi. 1 Fermi means 10 raised to minus 15 meters. Protons in a nucleus remains at the separation of this order. Whatever answer you are getting, that order will be remains there. Now, what is given first of all? Let's see what is given. Protons Q1 and Q2, two charges are given. Protons having the same charge, 10 raised to minus 19 coulomb. And the separation R is also given, that is 1 Fermi. 1 Fermi means 10 raised to power minus 15 meter. And the value of 1 upon 4 pi epsilon naught, we already know, that is 9 into 10 raised to power 9. Now using Coulomb's law, that is magnitude of the force is equal to 9 into 10 raised to 9 into 1.6 into 10 raised to power minus 19. Q2 is 1.6 10 raised to power minus 19 coulomb, and whole divided by square of the distance, that is 10 raised to power minus 15 whole square. Finally you will get 9 into 1.6 into 1.6 into 10 raised to power minus 29. Because 9 zeros are here, 9 will cancel out here, you will get 10, 10 or 19, that is 29, divided by 10 raised to power minus 30. 15 into 2, that is minus 30. Cancel out, only 10 will remain there. That's why finally you have the answer 9 into 1.6 into 1.6. And the force between two protons, that will be 230 Newton. My question for you, you need to find out force between two protons when separation is 1 centimeter. Whatever force you will get, you should remember it. That is very important concept. But here I am just solving the question number 6 from the SC Verma. Now what is question number 6? Let's see. In this question, two charges two charges, 2 into 10 raised to minus 6 and 1 into 10 raised to minus 6 are separated by a separation of 10 centimeters. Where should a third charge be placed such that it experiences no net force? That is the problem based on the equilibrium, electrostatic equilibrium. What is electrostatic equilibrium? At equilibrium, sum of the forces acting on that particular point will be 0. If sum of the forces are 0, let's see how do you solve this problem. You have to remember one important note. When there are similar charges, there are similar nature of charges in the question, just like equilibrium, then neutral point point always between them. Let's see here, we have two positive charge. One is Q. Let another is suppose that 2Q. Let both are separated by distance R. How would you say that equilibrium is always between them? In this side I will justify it. This is positive Q charge and this is suppose that positive Q charge. If you take neutral point over here, electric force due to another charge you have to put here, that is test charge positive Q. Force of repulsion between this charge at point B and A, that will be repulsive. If this is repulsive, forces F1 plus F2, they are added. If forces are added, it means there is no equilibrium. Similarly, if you take this side here also, force is also added. It means F1 plus F2 is not equal to 0. The only one option is there. Let you are putting suppose that point P over here and having test charge plus Q0. Force due to this A positive charge this side and force due to B positive charge this side. It means in this particular case what is happening, F1 minus F2 at 180 degree, vectors will subtract each other and finally answer will be 0. If answer will be 0, it means there are chances to balance these forces and get the answer 0. Then I can write F1 is equal to F2. This concept you have to apply whenever you have problem just like equilibrium. Here, we know already charges are given, they are similar. Let this is the point P, which is neutral point. Let this point is A and this point is B. Let this is suppose that X, then remaining distance is R minus X. By this way you have to solve it. Let's see, I am using the concept of equilibrium. F1 is equal to F2. K, what is Q1 and Q2? Q1 is 2 into 10 raised to power minus 6 into test charge, you know, that is Q0, and separation is suppose that X square is equal to K, that is similar, into 1 into 10 raised to power 6, that is 10 raised to power minus 6, into other charge, that is test charge Q0, whole divided by R minus X, means 10 centimeter is already given, that means 10 minus X in centimeter. Now KK will cancel out, 10 raised to power 6, 10 raised to power 6 will cancel out, Q0 and Q0 will cancel. What is rest now? That is 1 by X square is equal to, not 1 by 2 by X square is equal to 1 upon 10 minus, this is square here, 10 minus X whole square. Now further you have to simplify it. Taking under root both sides, you will get root 2 upon X is equal to 1 upon 10 minus X. Now simplify it, you will get that will be root 2 into 10 minus root 2x is equal to X. Finally, you can take this root to this side, that will be 1 plus root 2 is equal to 10 root 2. You need to find out the value of X. X is equal to answer will be, you need to solve it, that is 10 root 2 whole divided by 1 plus root 2. You can rationalize it also, but this is the answer. Here you will get the two answers, one from A, another from B. Let from A you need to find and from B you need to find it. Calculation part is left.